Hi all, Tony here from Immortality. Today we're at Life Science. Ant queens live 500% longer than workers. Now we know why. The queen lives for years while the workers live months. There is an ant colony. If the queen ant dies, eligible ants fight it out until one is chosen as the queen, and that queen undergoes a metamorphosis during its lifetime from a worker that allows it to live 500% longer, as well as making all the babies. Nicoletta Lanise must have gotten in her time machine and traveled to the future and got all the answers and come back and put it in this article. So that's how good it is. So the female worker ants of this odd species can become pseudo-queens by winning a duel after their true queen dies. How far would you go to increase your lifespan by 500%? One ant species engages in brutal colony-wide brawls to replace recently deceased queens. And the victor not only gains the throne, but also gets a dramatic boost to their longevity. Upon the death of a queen, Indian jumping ants, Harpegnathos saltator, battle to see which worker will take the queen's place. Winning the crown means more than pumping out eggs. It also means living 500% longer than the average worker. Now, scientists may have pinpointed how substitute queens slow their aging. Well, this is a great observation in nature that could be applied to humans. Well, they put it down to a protein called IMPL2, which counteracts some of the effects of insulin in the substitute queen ant's body, according to a new study published in Science. In general, the hormone insulin directs sugar from the circulatory system into the cells, where it can be used for fuel. The substitute queen, officially known as pseudo-queens or gamergates, in reference to the Greek words for married worker, must boost their production of insulin to contend with the incredible amount of food they must consume. If you want to make eggs, you need to have a lot of insulin because you eat constantly. So if you're going to make a whole lot of eggs, you need the food, the resources to produce them, but that disrupts the chemistry of the body, and so you need all of the subsequent processes, including insulin. Although necessary, this influx of insulin should theoretically come with a catch. In addition to helping shuttle sugar into cells, insulin sets off several nuclear chain reactions, some of which contribute to the aging process, specifically the AKT signaling pathway, which is involved in many cellular functions, ranging from metabolism to cell survival, can be activated by insulin and has been long tied to aging and age-related disease. So you have the IGF insulin pathway, which is known to shorten lifespan, and you have the inhibition of that pathway, which is a known longevity pathway, as we know from diabetics. So it's very clear from diabetics who require a lot of insulin that they are at a higher risk of all-cause mortality. So the queen is eating a lot, requiring a lot of insulin. Essentially, that should lead to a shorter lifespan. But she has a trick up her sleeve. So if a pseudo-queen starts pumping out huge quantities of insulin, in theory, she should age more quickly than the average worker ant, who doesn't make as much of the hormone. However, in the case of these ants, it's the exact opposite. The median lifespan of a typical worker ant is nearly 8 months, while pseudo-queens can live for about 3 years and 3 months. It's a huge extension of the lifespan. And interestingly, if a pseudo-queen is placed in a different colony with an already established ruler, she'll revert to being a normal worker, this plan said. These former pseudo-queens are called reproductants and have lifespans similar to those of workers. Somehow only queens and pseudo-queens, despite all their insulin, manage to survive for years on end. So they're able to turn this on and turn it off. Their team sampled tissues from saltator workers, reproductants, and pseudo-queens, focusing on tissues involved in metabolism and reproduction. These included the brain, ovaries, fat body, and organs similar to the human liver and adipose fat. Using a technique called bulk DNA sequencing, the team analyzed which proteins were being built in the sampled tissue. So by seeing which proteins were present in the cells, in the tissue, they concluded the pathways in which were active. As pseudo-queens make more insulin, their ovaries grow and develop so that they can carry eggs. The insulin directs the ovary maturation process through the MAPK signaling pathway, another chain of chemical reactions that can be set off by insulin. At the same time, the ovaries make IMPL2, the team discovered, which essentially blocks the AKT signaling pathway that could otherwise cause rapid aging in the pseudo-queen. IMPL2 secreted from the ovaries also makes its way to the fat body and provide an anti-aging shield to that organ too. The team determined the two main branches of the insulin signaling pathway, MAPK and AKT, appear to differentially regulate fertility and lifespan, with increased signaling in one aiding reproduction in pseudo-queens and decreased signaling in the other, consistent with their extended longevity. The team's next step will be to understand how IMPL2 blocks only the aging-related pathway, not the reproduction-related one. Okay, so let's break it down here. So what we have here is the insulin IGF pathway, known to shorten lifespan, being overly activated. And it's coupled with the activation of a stress response pathway, which could include DNA repair, mTOR inhibition, and perhaps cytoprotection proteins and other stress response mechanisms. And that is enough to offset the insulin resistance and proliferation and its likelihood to cancer and disease. Certain foods have growth factors in them, such as meats, dairies, and of course sugars. And with enough of these foods, these pathways are activated. These pathways have been well studied to shorten lifespan, and they lead to Western diseases. Take, for example, carnivore dieters. They seem to think there is some magic in the meat, while protein is only required up to an essential amount and none more, in order to not activate these pathways known to lead to disease and shorten lifespan. You bang in a Coke or a milk drink or a steak and you activate these pathways. That these pathways shorten lifespan and develop disease have been shown in many organisms and even humans. So it's hard to argue that activating these pathways leads to these problems with health and lifespan. While rapamycin, currently the best longevity drug to date with inhibition of mTOR1, something that can be achieved with caloric restriction, and speculating the calorie restriction activates more stress response system than rapamycin alone. The paper identifies the ATK pathway, the inhibition of ATK, and are they a rapalog, or do they also activate other stress responses not activated by rapamycin? The paper in reference is the paper by Walter Longo, Extending Yeast Cell Lifespan with Stress Response Activation, where that paper was possibly the most that yeast cell lifespan had been increased, and that was done with caloric restriction and the inhibition of the sugar pathway and the protein pathway associated with that stress response, that cytoprotection and everything that comes with stress response. So if we look at the ATK pathway, a drug could effectively inhibit mTOR1 through the pathway. However, we want a more comprehensive stress response activation. There are also a class of drugs that are ATK inhibitors. One study is about a drug called Oridonin. The paper in question is titled Oridonin Delays Aging Through the AKT Signaling Pathway. Quote, where Oridonin prolonged the lifespan of yeast by 48.9% and extended the average lifespan of naturally aged mice by 21.6%, Oridonin significantly improved the health status of naturally aged mice. Mechanistically, we showed that Oridonin delayed aging through the AKT signaling pathway. Does it have synergy with rapamycin, or is it a rapalog? Because if you look at the pathway, you could be inhibiting mTOR1 through the AKT pathway. Or could Oridonin have some synergy with rapamycin to be more effective than rapamycin? There are other ATK inhibitors, and they're utilized for their anti-cancer effect because that growth and proliferation pathways are inhibited. While no such plan is available that fully seeks to activate the stress response shown to extend lifespan and health span, and in ants at least, it dominates over the insulin-IGF pathway, you could be activating the IGF insulin pathway for more growth, more regeneration, more time in the gym, more hormonal androgen effects without the shortening of lifespan. Tony, over and out.